Section 3.7 Inverse Functions. A reversible heat pump is a climate control system that is an air conditioner and a heater in a single device. Operated in one direction, it pumps heat out of a house to provide cooling. Operating in reverse, it pumps heat into the building from the outside, even in cool weather, to provide heating. As a heater, a heat pump is several times more efficient than conventional electrical resistance heating. If some physical machines can run in two directions, we might ask whether some of the function machines we have been studying can also run backwards. In Figure 1, it provides a visual representation of this question. In this section, we will consider the reverse nature of functions. So here is a given function. There is x, there's your input, and the output is y. Now, can we look at a function where the input is now y and the output is x? So can a function machine operate in reverse? Now, we want to be able to verify that two functions are inverse functions. Now, suppose a fashion designer traveling to Milan for a fashion show wants to know what the temperature will be. He is not familiar with the Celsius scale. To get an idea of how temperature measurements are related, he asks his assistant, Betty, to convert 75 degrees Fahrenheit to degrees Celsius. She finds the formula, C, which is equal to 5 nights times F minus 32, and substitutes 75 for F to calculate. So we have 5 nights times 75 minus 32 gives us approximately 24 degrees Celsius. Now, knowing that a comfortable 75 degrees Fahrenheit is about 24 degrees Celsius, he sends his assistant the week's weather forecast from Figure 2 for Milan and asks her to convert all of the temperatures to degrees Fahrenheit. Now, after considering this option for a moment, however, she realizes that solving the equation for each of the temperatures will be awfully tedious. She realized that since evaluation is easier than solving, it would be much more convenient to have a different formula, one that takes the Celsius temperature and outputs the Fahrenheit temperature. Now, the formula for which Betty is searching corresponds to the idea of an inverse function, which is a function for which the input of the original function becomes the output of the inverse function, and the output of the original function becomes the input of the inverse function. Given a function f of x, we represent its inverse as f inverse x, and we read it as f inverse of x. The raised negative 1 is part of the notation. It is not an exponent. It does not imply a power of negative 1. In other words, f inverse x does not mean 1 over f of x, because 1 over f of x is the reciprocal of f and not the inverse. So the definition of an inverse function. For any one-to-one function f of x is equal to y, a function f inverse of x is an inverse function of f if n inverse of y is equal to x. This can also be written as f inverse of f of x, which is equal to x, for all x in the domain of f. It also follows that f of f inverse of x is equal to x for all x in the domain of f inverse, if f inverse is an inverse of f. Now the notation f inverse is read as f inverse. Like any other function, we can use any variable name as the input for f inverse, so we will often write f inverse of x, which we read as f inverse of x. And again, keep in mind that f inverse of x does not equal 1 over f of x, and not all functions are going to have inverses.